For a shift register, as we spoke on Monday, if I have, say, just 4-bit shift register, if I'm saying that this is my D0, in some textbook, D0 is the far right. If I say for now, this is my D0, D1, D2, D3. The output of D0 is feeding the input of 1. This is Q0, and this is D1. Output of 1 is feeding Q1, it is D2. Output D2, it is Q3. No, sorry, D3. Q2, it is D3. This is Q3. And this is D0. When I input, and all of those are tied to the same clock. All of those are tied to the same clock. One clock is feeding them all. If I input 1 in here, with the rising edge, it will go to Q0. Then nothing will happen because everything is at the very beginning. All of them are zeros. So I input 1, I receive the rising edge. At the rising edge, this one is here. The rest are zeros. And now I have another rising edge. This one will jump over here, and still D2 and D3 are still zeros. But what will happen to Q0? Q0, I entered just 1. So the next one will be 0. Please note that, unless you have another one. If I have just 1 input to D0, clock 1, it is here. Clock 2, it will be 0 because the next one is 0. I have only 1 and bunch of zeros, unless I have another one. Now I moved to D1. I have the 1 here, and this is 0, Q0. One more step. I will have 1 on D2, while Q1 and Q0 will go to 0. One more step. This one will come out on Q3, and Q0, Q1, Q2 will be all zeros. What will happen if I input to D0 1 0 1 0? I will get that trail. But at the end, I will have what? I have just zeros, unless you have something else. If you have a long trail of zeros and 1, it will continue and it will be pumped from one stage to the other with the clock cycle. Please note the input to D0 will never reach Q3 until we have 4 clock cycles, 4 rising edges, 4 rising edges to reach the output. The question is, how may I do that? How may I do that? There are so many ways you can do it. There are many, many ways to do it. But please note that when you program it, what will be my input and what will be my output? This is we need to ask ourselves about. Paige? Hello, Paige?
Hello?
What will be the input and the output of this 4-bit shift register?
Not quite sure.
When you are connected to the outside world, what do you give to this system?
After 4 clock pulses?
No, I'm asking about the wires. If I want to wire it, if I want to use the waveform generator, what will be the input and what will be the output?
I'm not quite sure what you're asking.
This is my 4-bit shift register. I have inputs, I have outputs. What will be the inputs and the outputs?
Oh, there's going to be 1 input and 1 output.
One input.
Two inputs, sorry. The clock.
Oh, yes. Okay, that's good. Thank you very much. Who else? Hello, Mohammed. Mohammed?
Yes.
Hello.
Hi.
Nice to see you with us.
Thank you.
Please, all my video are recorded, and on the announcement, you are going to see a link to YouTube.
Okay.
Please watch all of those.
Okay.
Okay?
Okay.
And if it happens to go to Facebook, you are going to find me. Anything you see from me, you should put a like, okay?
Okay.
No like, no pass, of course. Okay?
I'll make
Thank
sure
you.
to like. Thank you.
So you want us to go on Facebook and like you 4 or 5 times a day? Is that it?
Yes, please. Yes. The more you like, the more grades you get. That's a simple equation. Don't worry. Bernard.
So 100 likes
May
would
I
be
ask a question, please, sir?
Okay, ask before I ask. Go ahead.
You did this here. Can you see my arrow? You did 3 inputs. Oops, that's not
I did 2 inputs, D0 and the clock. And there is 1 output, Q3.
So we need a DN, a clock in, and a...
We need a D because this is serial input, serial output. So 1 for the data input, and it will go to D0, the first stage, and 1 output that will be taken from the last stage, the output of the last stage. Of course, and we need a clock.
I lost my screen. Can you tell me how to get it back?
You lost your screen.
Yes.
Can anybody tell him how to get the screen back? Tell you what, you know the magic of restart.
Ah,
Okay.
I got it back.
Okay, enjoy it.
Yeah, and I just went to Facebook and liked you once.
Okay.
So I'm up to a D- now.
You are approaching F, no problem. Now, this is my D0. The first stage will receive the serial input from outside and clock. And I will propagate until I reach my final stage output. And this will be the output of my shift register. Okay? Bernard? Hello, Bernard?
Who?
Owen?
Oh,
Owen Jose?
Sorry, what was that, Professor?
Yes, sir. Would you please tell me those green lines connecting the D flip-flops, what those will be? Are those input or output?
They output from one flip-flop and input to the next one.
So
Right.
I need to declare them in the entity as input or output. What should I do?
Wouldn't you have to declare them as inputs and outputs individually to each flip-flop?
How could I declare them? Should I declare them as input or output or something else?
Would they be inputs?
You have just said the same wire, it is input to D1 and it is output of Q0.
Yeah, I guess I'm not quite
Wouldn't
understanding
you-
exactly what you're asking.
Wouldn't you have to set like a logic statement, like Q0 equal to D1 or something like that, and then have your input and output be separate to those?
Anything that takes values, I have to declare it. I may declare it in the entity as input output, or I may declare it somewhere else as something else.
Would it need to be declared as a signal?
Yes, excellent. Since those are input and output, and those are internal, they don't reach the outside world. My outside world is just two inputs and one output. Those are internal signals, so they must be declared as signal. Okay? And signal is declared in the main architecture. Of course, we did many of these. Now, let's see the other program. It is 16-bit, not 8. Not the 4 that I showed you. Not the 4 I showed you, but 16-bit with load and shift. Those 16-bit to 16. with load and shift. Load means I have those 16 bit I have 16 input lines. Separate input lines. When I say load, those 16 input lines will go to D0 to D15. This will go to D0 to D15 when I say load and I have a rising edge. When I say shift, D0 will go to D1, D1 will go to D2, D14 will go to D15, D15 will come out. But I will have also 15 output, or I can have one output. If I have one output that is D15, it will be parallel in, serial out. If I have 16 output, that would mean it is parallel in, parallel out. But with shift register, everything is moving to the left or the right. I can have the choice of making shift right or shift left. And here, as you can see, the problem statements 16-bit VHDL process. When the load signal is asserted, register should synchronously load the value of DN, all of the values. When shift is high, bit 15 should load 0, why 0? Because it had its output. I finish with it. I am not giving any other inputs. Another shift, it will keep on pumping to the next one. The zeros will be pumping to the next ones. This is how the second one would look like. How to make those? How to make any of those shift register? There are numerous ways. And as I said before, we are not gonna reinvent the wheel. That means we have here just a moment, let me clear this screen.
Professor, please, question.
Yes.
Yeah, I was going to ask earlier, but for some reason you couldn't hear me. Can we go back to the previous slide?
Okay.
The 4-bit slide.
This one?
No, the one before.
This one?
Yes, Professor.
Yeah.
So with the input, we said it's 2 input and 1 output, correct?
Yeah. Yes.
And the information we put in is 1010, correct?
Where do you put it?
The 1010 is what we're entering into the.
This clock here, it is 1010 forever.
For error. Okay.
Yes, but this D0, it is your data. You are free to select your data.
Okay. If
I want to see this data is jumping from one stage to the other until it goes to output D3.
Okay. If the data on D1, D0 is what is 1010,
Yes.
what would we have at the output?
After 4 pulses, you are going to get 1 here. After
So
5 pulses, you are going to get 0 here. After 6 pulses, you are going to get another 1 here. After 8 pulses, you are going to get the last 0. You didn't input anything, so zeros will be trailed.
okay. But if we enter 1010 there, you say after 4 passes we get 1, correct?
Yes, after 4, you are going to get the first one. After 5, the second one. After 6, the third one, and so on.
But after 2, nothing happens. After 2 passes, we get
After
nothing.
here, I entered 1.
Yes.
This one, after 1 cycle here. Second here. Third here. After the 4th, it will be here.
Okay, so it only trigger after 4 passes, correct?
You have more than that. I need to see if you are inputting 101. I will see here 101 at clock 4, 5, 6. But you didn't enter anything. So after 6, I will get zeros.
Okay.
Okay?
All right, thank you.
Thank you, sir. Now we are here. How could we do it? As I said, there are many ways. And I want you,
I'm seeing you, not the screen.
yes, that's because you like me. I want you to search the internet for VHDL shift register. You are going to see many, many programs. As a programmer, if there is a program that exists, just use it. You don't have, as I said, to reinvent the wheel. So in this assignment, I want you to search the net for this shift register, understand it, very well understand it. I repeat, I don't mind that you work together. I don't mind copying from each other. But I want you to understand what you are writing and present it to us on Friday. We are going to share the knowledge. As I said, there are many ways to do it. One way, for example, I can say shift_left. This will make the whole thing shifting. Another way is to have a for loop. Do the same thing 4 times. Another way is to make the wiring. Take D0, put it in Q0. The Q0, put it in D1 equal. Assign it, and so on. So I need you to search the internet, find a program, copy, run. Before all of that, when you search for some program, you need to understand it. Some of those programs, or most of them, they may use statements that we haven't seen here before. So you need to search for this statement, understand it, because you are going to explain to us what is this statement. Okay? Any questions? Hello, hello, hello. Any questions?
Hey, Professor. So have you written out or posted online where to identify and how to build a signal in Cordis Lite? Because you said we could either do it input and output and set them equal to each other, or you could say we could do signal
I said there
registers.
are 100 ways to do it.
Okay, so you should say go look for
I
how to
want
do
you
the
to
signal.
search the internet and find a way that suits you and
Got
you
it.
understand it, use it, get it running, show it us on Friday.
Roger, Dodger.
Friday, we are going to have a big day.
I really wish I was going to be here.
Okay. Hello, Chad.
Yes, Professor.
Is it clear?
Yes, it is clear.
Okay. I made this search this morning and I ran into very interesting sites with even every site would have more than one program. So please, I want you to get trained on using the internet, on finding out these resources. Okay?
Can you hear, not you, but can the other students hear me? Isn't there a site, if we find a internet site that's particularly good, can we post it some way so the others can see it?
You can do that if you reply to my announcement. You can, it will be shared with everybody.
Okay, thank you.
Thank you. But I hope that we can get different ideas. Because if there is one site, I will have 10, 11 copies of the same site. But I need to share new ideas, new techniques of building a shift register.
Would you want the shift register to be with or without like a reset?
Read the assignment. Read the assignment, please. And concentrate on building the 4-bit first. Then the 16-bit, you can complete it over the weekend. But for now, I want you to, from, it is Wednesday until Friday, I want to see this 4-bit shift register. No matter what technique you are using, just understand it. Cameron?
Yes.
Is it possible on Friday we start with your tutorial about test bench?
Yeah, that should be fine.
Okay, so on Friday, the first presentation will be from Cameron. He will show us how to use test bench. As we are going to see it, and you have the handout with you, I need you to write down the steps he took, and if there is anything that needs more explanation, you write it down. I need from you just one program, not all the programs that we have, just one program to use test bench. One of the 4 homework programs, just use test bench, not all of them. Let's see our assignment for this week. We have done already homework 1 and homework 2 will be due on Sunday.
Could I ask a favor?
Yes,
Can you make the homeworks due Monday night instead so that we can ask one another questions on Monday?
Mm, done.
You're a wonderful person. I'll go to Facebook immediately.
Okay, please do. Let's see our assignments also. We have lab report. Lab 1 is due also October 10. That's today. Oh, that was 2 days ago. So please make sure that you submit those. Any questions?
Yes, on lab 1, there was a question about the instructions for the DE10 light. And I read the booklet, but I don't know quite what to write, just that I read the booklet and
Yeah,
understand pins.
yes.
Okay, that'll be sufficient. Thank you.
Yeah. Any other questions? Okay, that will be all for today, and please be ready on Friday to present your program. And of course, be ready for anyone to ask you about any statement, any word, any just one word in your program. Okay, thank you all. See you Friday. Bye-bye.
Thank you, Professor.
Thank you. Bye-bye.